So for Module 1, we're converting radical form to rational exponent form and vice versa. So one thing to note is that anytime you have a rational exponent, keep in mind that the denominator represents the root and the numerator represents the power. So if you look at example 1, x to the 5/6 power, the denominator always represents the root. So if I were to write this in radical form, it would be the sixth root of x, and the numerator is the power, x to the fifth power. If I were to write this the other way, so the cube root of x squared in radical form, the cube root of x squared, to write this as a rational exponent, x would still have a power of 2. And since it has a cube root, that would tell me that the denominator is 3. And for number 3, we also are dealing with radical equations in Module 1. You always want to check for extraneous solutions when you're dealing with radical equations, and extraneous solutions are x values that when you solve them, they don't work when you plug it back into the original equation. So if we look at number 3, the equation is the square root of x minus 1 plus 2 equals 6. Now, the goal here is to get x by itself. So anything that is on the left side with x that is not inside of the root is going to be the first to go. So I'm going to get rid of this plus 2 by subtracting 2 on both sides. And then from there, the 2's will add up to 0. I can get rid of them. The square root of x minus 1 is left on the left side equals 4. Now, x minus 1 is stuck inside of a square root, so I have to get rid of the square root. The way to get rid of the square root is a square. Whatever you do to one side of the equal sign, you do to the other side of the equal sign. And keep that in mind. The way to get rid of a square root is to square it. The way to get rid of a cube root is to cube it. The way to get rid of the fourth root is to give it a fourth power, fifth root, fifth power, so on and so forth. So in this situation, we have the square root and the square, which get rid of each other, leaving you with x minus 1 on the left side of the equal sign equals 4 to the second power, which is 16. Last step, I'm just going to add 1 to both sides, and this will give me x equals 17. Now my instructions do say to check for extraneous solutions, so I'm going to check if 17 actually works by plugging it back into the original equation. So if I check this, and I'm going to check it up here because I'm out of room, I'm going to rewrite the original equation by replacing the x with 17 and making sure that it works out. So 17 minus 1 is 16. The square root of 16 is 4. If I bring the rest down, 4 plus 2 does equal to 6, which means x does equal to 17.